The second question is how much do we order? Put differently, what is our lot size, which we have called Q? We have here two different situations. In both, we have the same graph that I explained before, but in the upper part, we have a graph where Q is smaller than the one we have here. So we can notice two things. First, the physical inventory goes all the way up from 0 to Q, and then it diminishes over time. But the highest value of the physical inventory is smaller than the one we have here. So on average, the physical inventory we have here is smaller, so we have a lower cost in terms of inventory because we have less amount of computers in our warehouse. But on the contrary, what we have is that since we place orders of a smaller quantity, we place those orders more often. So we have more triangles like this, which means that we have to place more orders and place the fixed cost more times over time. So in summary, in terms of costs, if the holding cost we want to keep it low, that would mean having Q as small as possible. But if we do that, if we have Q as small as possible, we have large ordering costs. So there's a trade-off. So we don't want Q to be too large because we don't want too large holding costs, and we don't want Q to be too small because if not, we will have too high ordering costs. So let's see an example. So let's imagine first that Q is it's a 500. In that case, we can compute the monthly cost. So first we have a computer's cost, which is the money we pay to our supplier because we have to buy the computers we're going to sell that month, which is 1,000 times the price we have from our supplier. This doesn't change unless we change our supplier. So this is not a relevant thing if we're going to have the very same supplier. The ordering cost is computed as follows. If we're going to to have a demand of 1,000 over a month and we are placing orders of 500, that means that we're going to place 2 orders per month. This fraction here gives us the amount of orders per month, and we're going to pay $4,000 per order, which means that we are spending $8,000 per month in terms of ordering. When it comes to holding cost, we have to notice that this red line here, which is the physical inventory that is relevant for our cost, our holding cost, we can compute it taking into account the average of this inventory, which is half the lot size. So the average inventory we have is half the lot size, which is a 500 divided by 2 computers, and we're paying $32 per computer a month. It means a holding cost of $8,000. Okay, the total amount we would be paying would be $16,000 plus the price for the computers. Let's now imagine that Q is 250. So the calculations are exactly the same, but we substitute some numbers. The computer cost is exactly the same, but the ordering cost is now 1,000 divided by 250. So that means we are placing 4 orders, which is natural. We are ordering less quantity per lot, so the total number of orders we have to place per month is larger. Actually, it's 4 orders per month. That means a cost of 16,000. And the holding cost now is lower because we have less computers in our physical inventory. So the largest, the moment when we have more computers, when we have 250, and on average we have half of it, which is 125 times $32 per computer a month. What we have is a total cost of, for a total holding cost of 4,000 euros. We have total cost of $20,000, which is more than the one we had before. So the reduction we have in terms of holding cost doesn't pay off when it comes to ordering cost because the increase here is large. So what if Q was 1,000? Again, the calculations are exactly the same but with different numbers. The computer's cost doesn't change because we have to buy all the computers we're going to sell over the month. The ordering cost changes, of course, because we're buying one single time per month, because we buy all the 1,000 computers I need, okay, and that means having one order, and we pay a fixed cost of $4,000 for that order. And as the holding cost, we have a larger holding cost because we have on average 1,000 divided by 2 computers, which is 500, and we pay $32 per computer a month, which means a holding cost of $16. In this case, it happens the contrary. So compared to when Q was 500, what happens is that we have just one order placed, so we're saving money here. But the holding cost increases so much that it doesn't pay off.